Cool. So as per usual, this is recording my screen share. If for some reason I either accidentally pop you guys up and while we're asking questions or whatever, we won't use any of your material without your permission. Um, and please, interject, ask questions. Let's make this as conversational as possible, and let's have a really interesting conversation about solar orientation and prevailing wind in site design. I find that solar orientation and prevailing wind is fascinating because it's probably the biggest example in site design of probably your most subjective decision making that you have to make in site planning, and that's really critical. The way the environment outside of the site affects what you do inside of the site is kind of the crux upon which the programming and analysis exam is built. That being the most subjective makes it arguably the most difficult exam in the ARI process. It's most people's least favorite to study for. It's most people's it's my least favorite to prepare, only because it's very difficult for me to give you a black and white answer to most of these analyses. You have to pick something that you feel is the best based on a lot of different inputs of information. So let's get into it. I have a lot of slides for this one, so I'm going to move really fast. If there's anything that I move way too quickly for that you feel like is really important to you, feel free to stop me. I think it's really important. But I think it's really important to also understand as we talk about PA concepts to understand the overlap with PPD. So essentially, if you think of the programming and analysis exam as constraints and possibilities, and the PPD exam as the design synthesis, so the beginning of the actual design of the structure, then you have to understand that there is going to be some inherent overlap between the two exams. That's an overlap in site, your context, and early code analysis. That also is an analysis of what happens on the site from a non-code perspective and from an environmental perspective. In the early iterations, probably the first iteration of the ARI 5.0 handbook, they had these two sample questions as examples for programming and analysis and project planning and design. The first question for programming and analysis states, an owner has selected a hilly site for a new two-story residence. The site is located in a temperate climate with winter winds predominantly from the northwest and summer winds from the southwest. Which location on the site is a favorable microclimate for passive heating, cooling, and daylighting. Now, in contrast to that, the PPD question that they had listed is very similar in its keywords. It states a new one-story daycare center is being planned in a hilly suburban location in a hot, humid climate. The prevailing winds are from the south. The client wants to use passive cooling. Which of the following strategies should the architect recommend? Check the three that apply. So if you think about it this way, right, the overlap that you see is obvious. It's dealing with prevailing winds, it's dealing with climate, it's dealing with passive systems, so passive heating, cooling, and daylighting, and then passive cooling on the other side. So there are a lot of similarities, but the differences are this. Programming and analysis requires evaluating environmental site conditions to inform siting. So that's part of like your pre-design analysis, the things that are going to be most important before you start the project. Whereas project planning and design, it requires you applying passive design strategies and environmental site conditions as a part of your early design integration. And that's really important because now you're actually working with the building, where programming and analysis, it's almost like it's a feasibility study. Will this work on this site? And if so, where? And what are the most major implications that are going to have an impact on this project when we contract for it? So let's start with wind. Um, Most importantly, for the programming and analysis exam, I want to say this just flat out. You do need to know your environmental analysis diagrams and tools. That is critically important. If you have not seen a windrose, you need to spend some time reading windroses and effectively just how they work. Windroses are fairly simple. There's usually, if you look in the bottom left here, a time frame. And so that could be 1 day, it could be the entire year, it could be an hour. But generally, the most granular it gets is 1 hour of time. And so what it's going to do here is tell you that the color band that you see in each of these directions is how fast the wind is coming. at you from that direction and for how much time during the allotted time period that you've established. So that's over 4,835 hours. Basically, if you calculate the depth of each one of these cardinal direction triangles, wedges, that would equal out to 4,835 hours, is how that breaks down in this one. So this tells you the velocity and how much time in each direction it's coming at you in that wind from that direction. So this basically means that in this location, downtown Knoxville, that most of the wind is coming out of the west southwest direction. When it comes to wind, it's important to understand structural implications as well. But that's kind of a broader understanding of how wind behaves around taller structures versus smaller structures. Whereas in the PPD exam, we're actually interested in where we're going to have positive and negative pressure a little bit more rather than a whole building understanding of what the impacts are going to be on the building. But we are going to talk about both today. We're going to talk about the behavior of wind, and we're going to talk about mitigation strategies for how wind behaves around massing of structures. First off, let's talk a little bit about ground speed. Ground speed doesn't really change in terms of what is on the ground, but the wind speed does change relative to the height of the structures by a slight parabolic relationship, or I guess that would be a hyperbolic relationship. I haven't had math class in a long time, and I always get these backwards. But if you notice, the wind speed here at where there's no buildings is going to be greater at the ground than it is where there are tall buildings and in a mass of different structures that are kind of breaking up the wind at the ground plane. So the higher you get up in development, the more impact you're going to have on how much ground wind there's going to be, with some caveats, which we will talk about later. So let's talk about wind behavior near bodies of water. This one is a little bit less intuitive, right? We've all probably walked around cities, and we've been in an alleyway where there's a gust of wind and it hits us pretty hard. But it may not be that we've necessarily noticed the difference between standing by a body of water in the middle of the day and standing by a body of water at night. And been able to have a wide awareness of how they behave. But essentially, in the day, breezes will generally pull in off of a body of water, and they shoot up. And then adversely at night, the wind will pull out to the body of water and push up, based off of the temperature and pressures of the air, and as it's moving through our solar cycle. It's important to understand that valleys behave particularly when it comes to wind. And this is not only important just for designing for comfort, but particularly here in California, fire. Because fire is going to move very swiftly in the direction that high wind pressures are going. So in the daytime, if there's a valley, the wind is generally going to push up the valley and out to the sides in kind of like a thrushing fashion, almost like a boat going through water, like a speedboat going through water, and it pushes the wind out the side of the valley. So generally speaking, it's somewhat ill-advisable when it comes to wind to put a house right on the edge of a valley, and yet we do it all the time. We do it for the views, because vista views are much more valuable, and we can mitigate that by doing something like putting a windbreak in front of the house to kind of break it up. So it could either be a wall of glass that shoots it up over the house instead of at the house, or it could be a mix of foliage that breaks up the wind as it climbs up the valley. And we're going to talk about some of those mitigation strategies here coming up soon. But at nighttime, wind will actually mass down the valley. So the wind goes back down into the valley and shoots down the valley where it opens up at the bottom. So that's critically important to understand the difference between the two in daytime and nighttime. They're the same when it's a body of water and when it's a valley. Body of water and a valley, when it's daytime, will shoot up and out. And at nighttime, wind is going to shoot down and into valleys and out to the water. But then at night, once it gets out to the water, it's going to shoot up. But we're not designing structures in the middle of the water anyway. So what do we care about that part? Let's talk about wind around an obstruction. So this is in plan view. So if we have a building that's a square profile, it's going to look a little bit like this. Part of this that we are concerned about in PA is shown, and then some of it that we're concerned about in PPD is shown. Um, as the wind hits the left side of the structure, because that's the direction it's going to have positive air pressure on that facade. But the wind is essentially going to split and move around the building. And as it swirls on the backside of the building, it's going to put negative air pressure on the other side of the building. That's really important because our comfort zones are going to be around where the building has pushed the wind. You're going to get less turbulent air in your trailing corners of the building. So at this corner and at this corner is where you're going to have the calmest wind around that structure. When looking at it in elevation or in section, you're going to have your most positive air pressure is going to be kind of down the bottom of the building, and most of it's going to foil around up top, and you're going to have a mild or medium amount of negative air pressure on the backside of the building, the trailing part of the building. That's why when you see, maybe you won't know this, but if you often see a rooftop deck, usually there's some sort of windbreak on one side of the deck, and that's usually going to be the leading corner of where the prevailing winds are going to be. So the windbreak would be up there, and then the deck is going to exist at the trailing end of where the prevailing winds are going to be. And so let's get into some mitigation strategies. And again, we're kind of moving through this very fast because I have a lot to talk about on this one, but stop me at any time if you have any questions. One thing I just realized I don't have open is the chat in case you're chatting instead of jumping in to ask questions. So I have that on now, so feel free. Let's talk mitigation. Um, One of the things that, like, one of our most powerful tools, and you see it all the time, perhaps, but if you haven't learned about it, you might not realize why certain things are laid out this way. So if you drive through kind of the heartland of the US enough, you'll see that there are these lines of trees that are aligned along either crops or very wide open fields, or they might be lining a driveway up to a house or around a house in the middle of a field. And that's because wind screening with trees is profoundly powerful. A 30-foot tree can essentially block, or rather, a 10-foot tree can essentially block up to 300 feet of, not block entirely, but it'll have a scalar impact depending on the distance of essentially mitigating that wind. It'll be most effective right next to the tree, obviously, but it can have a profound impact up to 300 feet. So it's 30 times the tree height. So that's important because this is used in farmland quite frequently. It stops blowing, valuable soil off of the crops that we have. So that's why there's tree lines around some of our crops that are most valuable or most exposed to soil wind erosion. Likewise, just the comfort of housing and design of your site and construction. To create tree-lined walkways in a windy area or to use trees, whether they're evergreens in a cold climate or if they're going to be deciduous in a warm climate. These are things that we need to consider when we're designing for comfort among our site design. We'll talk a little bit more about that. Secondarily, hurricane and coastal storm mitigation is going to utilize, rather than wind and solar pressure, it's actually going to use mechanical mitigation techniques. So while we think about wind and solar and we think about the environmental impact of other systems on our site, when we're thinking about hurricane and coastal storm, there's not much we can do in a passive way, or not much we can do in a way that utilizes the other elements. I mean, if you've got a storm, you've got a storm, and you've got to mitigate that with structural design. So let's talk sun. Once again, the sun path diagram is absolutely critical to know. You will almost definitely encounter this on the exam, and you have to know how to read it. It's fairly simple, where let's say the sun vector center point is going to be roughly the center point of your building. All sun rays are assumed to travel parallel to each other, and we'll explain that in a later slide. Essentially, the way this diagram works is that wherever the center of your site is, there's going to be an altitude angle of the sun that is going to follow a certain date. And the dates are going to be these horizontal bands that are wrapping around this diagram. Because of the way the winter, the solstice and equinoxes work, effectively, our summer solstice is the top band, and our winter solstice is the bottom band. And where, if you look at just in this vertical axis here, um, the highest point in the year is going to be at the summer solstice, a little after 12 noon. So that's about going to be a particular time of day. This 12 noon little kind of infinity symbol here, that's at 12 noon throughout the year. Um, and so we're going to kind of dig into that in a few future slides. But those represent the time of day each hour as it goes throughout the year, or it goes throughout the day and throughout the year. Our equinox line is going to be right here. So that's going to be in March and September, and then winter down here. So where this falls is our azimuth, or sorry, our altitude. And so our altitude at the highest point in the year is going to be just above 80, or just below 80, I should say. So that's like 77 degrees. And then if you look at the rings on the outside, 2030, so that's 2030, is that right? Yeah, 30 is down here. And yeah, it's about 30 degrees. Um, that's a profound difference. So we're looking at sun angles that are going to be coming in at super high, around 77 degrees at the highest point, and then around 30 degrees at its lowest point. So that changes the way the sun hits a building, and it also changes the way it casts shadows. So we're going to go through this part rather quick, because I think you might have seen this before. But if you haven't, the Prep ARE course does have a slower, more detailed explanation of how this works, constructing the whole diagram from the ground up. So if your building has this orientation roughly centered in this location, this is Knoxville, Tennessee. At 2 p.m., the sun is at this point in the sky. So it's roughly 60 degrees high, and it's casting from this angle to our building. So when I say that the sun is presumed to travel perpendicularly, um, it is, or sorry, parallel. It is because the sun is so far from us that the sun angles we're getting, it's totally imperceptible the difference from the point of the sun to how much it displays across any object at our planet, just from how far we are. The shadow is going to be cast at that angle at all corners of the volume. And so let's talk about the shadow length, right? The altitude angle is going to define what our shadow length is going to be based on the height of the structure. If the structure is higher at the same time of day, of course, that shadow length is going to be a little bit longer. But likewise, if we consider different times of day, sorry, that's going to come up later. Yeah, there we go. It just skipped it. So if we consider different times of day, then we're considering at 4 p.m. our shadow is going to be cast longer because at 4 p.m. The altitude is going to be different. Now it's down at 40 degrees. So this is all critically important. By the end of the day, we're going to have essentially 0 degrees. That's when it hits the horizon. Um, and as we consider the change in the shadow and sun angle throughout the day, it's going to have a profound impact on how far that shadow gets cast and how far the sun will enter and leak into the space. Um, Building orientation is really important when it comes to this concept, right? So if we have a 77-degree angle at the summer solstice, that's a very high angle that the sun's coming in at, and we don't want to allow the sun in the summer in general, right? And so if we're looking at the south facade, if we have a building that's oriented east-west like this, and we look at the south facade that's going to get the most sun throughout the day, what kind of sun shading do you want? Do you want vertical louvers? Do you want horizontal shading or horizontal louvers or just an overhang or something like that? Um, it behaves differently because depending on the climate, If you want the sun to enter your space or you want to shade it from your space, you have to consider which type of louver, which type of overhang, and how long it has to be. In the summer, in a place where you do not want the sun to enter, you can have a relatively short overhang or very short horizontal louvers on the south facade. On the east and west facade, that's going to act a little different because that's where you're going to have your sun rising and your sun setting on the other side. And the way that the sun's going to move across the sky is going to be a little bit more angular rather than vertical. So vertical louvers work very well on the east and west orientation. And overhangs generally don't work very well because the sun is going to be almost at the horizon level, so you're going to get blasted with a lot of sun. So that's kind of the general predisposition of sun control around building orientation. So let's talk building shape. The shape of a building is it directly affects your ability to manage sun and the environmental quality of the space inside. So your narrow and elongated buildings, they allow more rooms to have access to more sunlight, whether it's direct sunlight on the south side or indirect sunlight on the south side. And so you can control glare and heat gain quite quite a bit better than some other configurations. Um, for L-shaped or U-shaped designs, these are best for creating shaded outdoor spaces and improving natural light and or breezeways or implementing a natural airflow into a building design. For courtyards and atriums, these are best for kind of allowing sunlight to cascade deeper into a building configuration, especially if you're limited to something that's a little bit more, square or kind of a tighter rectangle than the elongated format. This also helps reduce reliance on artificial lighting and allows that natural light to help with kind of just the interior environmental quality. And then finally, compact and deep squares. These ones are not really great for daylighting. They're much more challenging. They often will require skylights or other advanced strategies. So these are kind of more industrial kind of style designs and where you're not really relying on environmental conditions to create comfort. So we talked about integrating landscape for shading. Landscape can be integrated for shading quite effectively. It won't solve all of your issues, but especially in some issues like a commercial condition at the first floor with a residential condition on the second floor, your commercial condition might want more of a sun break or more controlled light. But then your residential condition on the second floor could want more natural light to leak in above, say, a tree that's going to be placed next to the building. So oftentimes there are these metrics that can be used, but of course the only metric that really matters at the end of the day is how tall is the mature height of the tree, what is the angle of that tree, or rather the spread of the tree in some ways, but what is the angle of the peak of that tree to the building, and what does it block at what times of the day. Generally speaking, in commercial corridors, it's a good idea to put a tree outboard of the exterior of the building face that you're trying to control, about a quarter to one-third of the mature height of the tree. So let's talk about some responses to some of these designs. As we talked about the sun angle and how to control it and why you would control it, it's really important to consider when looking at the slope of a site and which direction the sun is going and what sort of configuration will your building take if you put it on a slope or on a flat ground on the peak or something like that. What is the meaning of its direction? So this is just a great example of what is the impact of how you control sun when you're facing north or facing south. So the building facing south has plenty of opportunities to allow overhangs to control summer sun. You see that in the left corner of the top diagram, and allow winter sun to come in. This is critically important for the essential fundamentals of building orientation. Um, when it comes to the programming and analysis exam, we're not at the level of designing a building yet. It's uncommon that you'll be given or considering an actual sectional design of a building at this level, but you will be thinking about what strategies can I employ if I have this building face the south direction versus if have it face the north direction. Secondarily, we have to consider what type of program is appropriate if we have it face the south direction. So what type of program is appropriate for winter sun to cascade halfway into the space, or even a middle space? Do you want direct sun in the winter and reflected sun in the summer? And is that desirable? And so opposite, when you're facing north with a similar configuration, you're essentially blocking all of the sun from all of those interior spaces, and what spaces will need diffuse light that's coming in from the northern sky. So these are all kind of considerations and decisions that we'll be making from a strategic perspective at the earliest stages of design in the programming and analysis exam. Um, So we talked in the very beginning about climate and what that has an impact on. It is important to, and we don't have enough scope in this discussion to go through all of the different climatic considerations and the different climatic uh, categories that we must consider. They are covered in the preparatory courses as well as any of your other study materials that you'll be going through. But to have a functional understanding of what it means to be in a cold, dry climate versus a hot, humid climate or a hot, arid climate, these all have different implications on what decisions you make throughout the site. And we're going to look at a couple of examples right here. Um, in a cold northern climate, wind is going to be very critical because the winds are brutally cold. So if your wind rose is showing that your primary wind is coming from the northwest direction, and you have a secondary wind for the other part of the year that's coming from I guess this would be um, west northwest direction. Um, or I guess it'll be northwest. All right. Anyway, but you have those kind of two primary concerns, but you have a lot of wind you need to block from the northwest, and so you'll kind of guard your building from the northwest. And on the secondary side, sorry, the northeast, I said northeast, I should have said. And then on the left-hand side, we have the secondary wind direction coming in from the west. We just block that with some deciduous trees because depending on what type of tree or what type of blockade we want at what time of year. So in the winter, that's going to be able to allow some sun, some wind in, but you're going to have some evergreen trees over here to help block the winter wind that's going to be coming in from the primary direction. Secondarily, now that we're considering wind, we're also considering sun. If our wind is coming all from the northern hemisphere or the northern direction, then we have freedom to completely open up our site to the south and allow as much sun in as we wish, which is valuable in a winter climate. We want the sun to come in on the south side. That'll help warm up the space and keep it comfortable while blocking out the wind. Secondarily, let's look at a hot, humid climate with a primary wind that's coming in almost directly from the west, and we have a secondary wind that's coming in out of the northeast. So in hot, humid climates, it's actually desirable to capture some of this wind because it helps alleviate some of the humidity and heat that's gathering inside of your space, especially in a livable space where humidity is compounded by, the uses of how a building lives and breathes. We're creating humidity ourselves. We're running hot water for showers. It's critically important that we capture that wind and use it to clear out the humidity and heat that's gathering in the space. Um, in this case, what we're doing is using less deciduous trees or sorry, using less evergreen trees, mostly deciduous trees, to allow for some winter sun to come in if we can, especially in the southern direction. But then when we have in the summer, when it's going to be most hot, we want to we want to essentially block more of the sun from the south side, and we want to allow the wind to pass from those other two directions that we have wind coming from. So that's kind of an amalgamation of strategy, and this is why it's very difficult to teach this subject because it's a whole lot of information that we have to study. This is all just being studied from the two-dimensional direction. The only thing that is helping this is that we are looking at evergreens and deciduous trees. We're not yet considering the vertical direction, how tall the building is, how tall the trees are. It does get more complex, but let's look at some more. So that was kind of a more, I guess, rural example where we're looking at one building with essentially a few other contextual considerations around it. But what happens in a more urban environment or where we have to lay out multiple buildings on a site? How does wind behave? We talked about the way that wind hits a building on the leading edge, but we have to consider as we have tall buildings next to small buildings that prevailing winds are essentially going to hit that building and they're going to go down and they're going to go up. So if you have a park or plaza that's in between a tall building and a small building, that's going to create a pretty chaotic wind environment in that location. Do people who are spending $5 billion on a skyscraper really care? Barely. But one of the things we have the luxury of considering in the ARE space is that, if there's enough money in the project to truly study this, and there's enough stakeholders like city planning boards and communities that are considering master plan development, they may want to pour some money into truly studying the wind science and the physics of the wind in a space like this. But the reason we are tested on the ARE for this is that most projects don't really have the budget for that. And so we need to have an intuitive understanding of how wind is going to behave in these conditions to make informed decisions for our clients in the future without getting a test, spending a lot of money on testing for situations like this. Um, so understanding prevailing winds in that situation will create a chaotic situation. But similarly, if we have two buildings on a site that are starting to coalesce into a wedged condition, the prevailing winds are on the wide side and they're passing through this axis in between these two buildings. What that's going to create is a super high velocity wind tunnel, which is also going to be similarly uncomfortable. This is one of the most common problems that happens sort of in like foothill developments and mountain towns that may or may not have like tree coverage, especially in California where we have semi-desert climates and stuff. Um, so, what do we do about this? There are plenty of ways we can employ similar strategies to what we did before, what I showed you in the simplified diagrams. We can start to look at implementing trees or sculpture gardens or some other programmed way of designing the site that will help block some of those prevailing winds. Of course, we have to consider what climate it is as well. Do we want deciduous trees? Do we want evergreens? And so essentially, what we can do is employ some of these site design strategies to break the prevailing winds into an acceptable velocity. And then secondarily, we can utilize things like a tall building on the side of our site. The tall building on the side of the prevailing winds will help break that wind and create, there will be a little bit of a foiling wind on the other side, but it won't be quite as bad as it was before. You may want to block some of the wind going through a small alley or corridor like this. But those are ways that we can employ wind breaks in such a situation. And then lastly, on this particular example, I wanted to talk about site design. One of the things that we do consider is threshold, right? As we're laying out buildings around a site, we have to consider what are the primary ways of entering a project site. Of course, corners are going to be the most valuable place that you can enter a project site. It's going to have the biggest foot traffic, the most exposure. So it's either going to be if there's one single development, you'll have like a anchor store or something on that location, or you'll have a big threshold to bring you into the mall, for instance. Um, but that's critically important because we want to treat that location with care in considering how it's going to relate to the environment around us, whether it's going to have have some sort of solar consideration because there's a very tall reflective building north of it, or if we need to do something to break winds that are going to happen if we happen to have a high velocity wind coming through this place. It's not going to be comfortable to walk into. So these are all considerations of us from for not only practice but for the ARE, because we're considering the sun, we're considering wind, and we're considering program, and we're considering site design concepts of circulation, access, user comfort, and all of these things all at once. So before I jump into some of our examples, I just wanted to give you guys an opportunity. That was a whole lot of talking. We had a lot to cover on that one. And you guys were very patient on just kind of listening and considering what subject matter we were going through here. But I just wanted to give you an opportunity to respond or ask questions if you have any. Okay, cool. Yeah, it's a lot. It's a lot to consider for that one. And I want to, before I go further into these examples, I I do want to kind of say that there's almost all of the resources that are listed on the NCARB reference matrix are fantastic for this content. And you can't go wrong by studying as much as you possibly can. Might it not be on the exam? Possibly. There's a lot to consider. Um, but it's going to be the type of intuitive understanding of how physics meets like the kinetic physics of the environment meets the static physics of a building and of a place, indoor or outdoor, that will help you your entire career. Yes. All right.
So these examples, we used like a cold climate, and then there was the hot, humid climate.
Mhm.
Would we maybe answer a question differently for hot, dry climate? Like for the wind question, would there be a different approach?
Uh, yes. In that case, like you probably want to have wind enter your space, and you could want to employ a way to collect humidity, whether it's like a reflecting pool or something like that that happens on the prevailing wind side. That's often used in desert design. If you can have a water feature on the prevailing wind side, it actually brings some humidity into the space, which is something you like. Um, it won't necessarily get trapped there. It doesn't, humidity is not something you want to design to keep. So you will release it, but you do want to bring as much humidity as you can. Secondarily, you can block a lot of the sun using like high mass, like trombe walls, or I forget how to pronounce that. But the high mass walls and features that will collect heat throughout the day, those are things that you could employ, but that's more of a PPD implementation, whereas like a programming and analysis implementation would look at where's the body of water on site. And if it's a hot, arid, or dry climate, you may want to put your building on the opposite side of the water from where the prevailing winds are.
Cool. Okay, thanks.
Mhm. Any other questions before we proceed? Oh, and another comment on this. Um, I talked in the very, very beginning about the overlap between programming and analysis and project planning and design. I think that this is the one specific area where it very much behooves you to study both at the same time. Not many people suggest that you must or should study PA concepts with PPD concepts, but some suggest you might want to. I think that you should in this particular subject matter. Um, okay, let's jump into some examples. I'm going to go with the same kind of disclaimer I give before these questions each time. That is that these are not necessarily indicative of the complexity or robustness of the ARE questions. These are not meant to simulate the ARE. These are meant to present different perspectives on this subject matter that the ARE might take. So let's focus more on the subject matter, less on the I guess nature of the question itself. So, one type of question that might relate to solar orientation and wind is solar orientation as it relates to building placement, as we just talked about. So a client is selecting a location for a small community center on an open site in a temperate climate. The program includes a multi-purpose room used throughout the day, several offices, and support spaces. The client wants to reduce unwanted heat gain while still allowing useful daylight into regularly occupied spaces. Which siting strategy is most appropriate during early design? The options are place the building so the longest elevations face east and west, place the building so the longest elevations face north and south, place the offices on the west side to receive late afternoon sun, place the support spaces on the north side to reduce daylight exposure. This one is going to be B. Some of the other options might have some merit to them. There are ways that you could design, for instance, offices on the west side of a building that could still be comfortable. Um, but really, we're in the programming and analysis phase, and the question is asking which siting strategy is most appropriate, not which programmatic location strategy. And so the longest elevations facing north and south are going to be your best way to control sun on the south side. Um, we have another one for prevailing winds as it relates to site comfort, and that was kind of what we were talking about in some of those latter examples there. A proposed library site has a strong winter winds from the northwest and a desirable summer breeze from the southwest. The program includes a main entry plaza, outdoor reading terrace, and parking area, which planning recommendation best responds to the wind data. Place the main entry plaza directly on the northwest side to increase visibility. Use building placement or landscape buffers to protect occupied outdoor areas from northwest winter winds. Block all southwest winds to prevent air movement around the building. And locate the outdoor reading terrace at the most exposed corner of the site. All very different directions, the right choice being using your building placement or landscape buffers to protect occupied outdoor areas from northwest winter winds. We want to allow them from the southwest and we want to block them from the northwest. So that's essentially what the question qualified in the very first sentence. Another question example direction might be considering existing site features with regard to solar access. An architect is evaluating a site for a new childcare center. A row of mature evergreen trees is located along the south edge of the buildable area. The client values outdoor play areas with sunlight during winter mornings. What should the architect identify as a potential planning concern? Evergreen trees may reduce winter solar access to outdoor play areas. Evergreen trees will only affect solar access during summer. South side vegetation has no impact on site planning decisions. The trees should automatically be removed before programming begins. So this one is very clearly going to be A. The trees, because they're evergreen, they will reduce winter solar access to outdoor play areas. Um, Another direction this one might choose is to show you examples of site layouts and say which of these site layouts is going to be best. And it may, be able to orient, a tall part of the building on one side, a low part of the building on one side, with the play area being kind of on the northern edge of the short area or something like that, so it's not blocked by the trees, something like that. And then another sample question. It may actually jump into some program adjacencies with regard to environmental criteria, and this is where it gets a little sticky. It may ask you about specific program or primary program of a building, but remember, we're not designing the building yet, okay? So the question might look something like this. A project includes classrooms, storage rooms, mechanical spaces, and an outdoor gathering area. Climate analysis shows harsh afternoon sun from the west and desirable morning light from the east. Which program planning approach is most appropriate? Locate the classrooms to take advantage of controlled daylight and place less occupied spaces where the exposure is less desirable. Locate all storage rooms along the east side to preserve western exposure for all classrooms. Place the outdoor gathering area on the west side because the afternoon sun is always preferred, or ignore solar orientation until the construction document phase. So this one being locating the classrooms to take advantage of controlled daylight and place less occupied spaces where exposure is less desirable. fairly obvious on that one. Not a super challenging question, but it does illustrate that it may ask you for some program adjacencies as it relates to site planning, particularly if there are, in the PA exam, if there are tight sites where it may have a profound impact on how you lay out the site with regard to project feasibility. And then I think this is our last example. Um, so it says site analysis shows that the best solar orientation would place the building's long axis east-west, um, allowing the primary occupied spaces to face north and south. However, this orientation would also place the main public entry on the northwest side of the building, where strong winter winds are common. The client wants the entry to remain visible from the street. Which site planning strategy best balances these requirements? The options are to keep the preferred solar orientation and place the main entry on the northwest side by using a recessed entry court, landscape windbreak, or low sight wall to reduce wind exposure. You could rotate the building so the main entry faces away from the wind, even if this creates long east and west exposures. C is move the main entry to the rear of the building so it's fully protected from winter winds. Or D, ignore the wind concern because prevailing wind is addressed during the mechanical system side. Um, this one again, fairly obviously going to be A. But just trying to understand that you may be considering, you may be asked to consider a trade-off about certain values of the site and with different options of how to approach the site, whether that's going to be in narrative fashion or in graphic fashion. Graphic fashion, sorry. Um, so, yeah, I think these are probably some of the easier of the examples that I've given you in the examples section. But I do hope that they communicate the breadth of angles that the ARE might take in asking you to prove your competence in this subject matter. So that said, that's the end of my base presentation. Let's jump into some chatting. And I'm going to pull this across here. There we go. All right, let me get some water because that was a lot of talking. All right. And I guess let's open the floor for questions. If you have any, it's possible you don't. But, I'm here to be a resource for you. I hope that was helpful. I do want to ask, though, if you're willing to share, how much of that was new information versus how much of that is stuff that you kind of already knew?
This felt like mostly review for me, but I think one thing I've noticed in some of the practice problems I'm doing is that these concepts will be mixed in with other, citing concepts that are maybe more about, access or, what is the surrounding context and circulation concerns.
Hmm.
So how to balance the different parts has been something that I've been, having to think about a little bit more than these examples.
Hmm. Yes, it certainly gets more complex the more layers you put in the analysis. This being like, this is step one. These are the things that you must have a mastery of in order to get to a point of being able to amalgamate that information into a good response. But I do think that the example at the end there about, the prevailing winds with the wedge-shaped site and creating the high velocity sort of threshold, but if you're trying to access at that point where it's creating high velocity is a good example of that as a layered analysis. But yeah, I hear what you're saying. The exam is going to be complex. It's understandable that you'll need to analyze all of that in a layered fashion.
Mhm. And then the exam will have questions where you have to kind of like draw or move different components around, right? It's not all multiple choice.
They got rid of the drag and drop.
Okay,
So there's no more drag and drop. But they do still have hotspot questions. And let me pull up an example. Um,
that's good to know. Yeah, I might be using old
yeah.
materials.
I'm just going to Google one because it's going to take me a very long time to find our question that has a hotspot one. Currently
But
not
that's
logged
just like
into it.
select the area where this thing is happening.
Yes, but they'll also have multiple choice with. So yeah, here's a good example. Um, so let me just kind of start by discussing over this, and then get into that. So yeah, hotspot question will kind of look like this in the context of, I guess let's say this was a site plan, and these are topography lines. You'll basically like pick a spot on site that says like you're either going to be at the ridge or you're going to be down in this valley or on that slope or down in this valley, you know? So that's the hotspot question, but there's multiple choice questions with graphic answers. This is not great. I need to have these pulled up on the side in the future. But I mean, you'll have like a selection of four choice with. Yeah, Googling's not fun for this. But let me just describe it to you. So like it'll have potentially, let's say you're looking at a site selection analysis, for instance, which might be a thing. It'll say this is the program that your client has requested you to do a feasibility analysis on, and these are the four sites they're considering, and which site is going to be, most conducive to what they want to achieve, based off of these factors. And it'll have a graphic of like the topography of this site, the topography of that site, the topography of that site, and that site. And so you'll just pick through the graphics as a multiple choice question. They've actually really simplified some of the question types, the item types that they work with now. But that's actually a good note. I'm going to write down that I should have examples of those in those various formats.
Appreciate it. Then another little clarification. You were mentioning that it might be helpful to study for both EA
Yes.
and PPD at the same time for certain subjects only or in general.
Well, here's how I would challenge you to consider that for yourself. Um, it'll never hurt to study more. But we are all professionals. We all have lives. We're not here to be slaves to the system of becoming an architect. We're here to live. And part of the challenge of passing the ARE is how much we balance our time between, our professional goals and what our personal lives demand. So when I say something like, this is a must study, I think that that is probably something that you should be thinking about it from both perspectives. Like to have an understanding of what environmental analysis is, like off-site contextual analysis of environments and their impact on the site in terms of where you put a building. Um, and then is one thing, right? And that's the bare minimum you need for programming and analysis. But if you think about it from the project planning and design perspective, the concepts of how you shade a building are a lot of the reason why certain things are what they are. So while you're not designing a sun shading system for a building at this stage at programming and analysis, having a functional understanding of why the building in the east-west axis with the longest face of the building on the south and north is going to be, most economical and functional is a concept that straddles both lines. Does that make sense?
I think so. Just
Yeah.
having your basic understanding before you get too granular.
Right. Yeah. But then there are other things like trombe walls that you kind of like it could help to know that like using a trombe wall on the south side or the west side and not the east side is going to be helpful. But but you're not going to be asked a question about locating that on the programming and analysis exam. That's a project planning and design question because it's an element of the building. Or at least if you do get asked that, it's technically, in my opinion, not supposed to be there.
Okay, I've been seeing those in my practice exams, so that's, that's how it is.
Yeah. So, it's this is one of the most difficult lines to draw in all of the ARE, and it's why I don't love teaching it because I don't feel extremely confident in giving you that advice. What I can tell you is when I read the specifications of the exam and in all the experience I have, teaching it, that is where the line is supposed to be drawn. But remember, the people who are writing the exam are volunteers. They might not even know where these lines are supposed to be drawn as much as I do. And the people who approve it are not necessarily looking at this every day. Like the people who are approving it for, is this question accurate? Does it follow our item rules? And then boom, here it goes. But there's not as much oversight on does it truly belong in this exam or that exam.
Interesting.
Yeah. So, I mean, if you really get down to it and if you have conversations about like the gripes people have had about certain questions on the ARE, there's a lot of, what do you call it? Grievances over stuff like this, you know? So I would say as much time as you have to straddle that line and study these concepts, like do study trumpet walls. I'm not saying don't, but I'm saying if you only have time to study the way wind flows across a site and how to, um, how to collect humidity off of like waterfronts and stuff like that, then focus on that because that's more in PA's wheelhouse. Cool. Glad that helps. All right. I think we're kind of running out of time here, but if you guys do have any other burning questions, I'm happy to stick around for a few more if you'd like to ask them.
Appreciate.
All right. I've kept you two from your bosses for 3 minutes too long. So, all right, get back to work and I'll see you next week, hopefully.
Thank you.
All
Have a
right.
good
Feel
day.
free to reach out on discussions if you need anything in between.
Thank you. Bye.
Oh.
All right. Bye.